Hello, thank you for watching this video. Today we will be talking about Chapter 3 of CCNA exam, Point-to-Point Connection Part 2 by me, Astrid Krasniqi. Point-to-point connection, we'll start with introduction to point-to-point protocol, advantages of using PPP, PPP Layered Architecture, establishing a PPP session. Then we'll talk about point-to-point protocol configuration options, PPP basic configuration commands, verifying PPP encapsulation configuration, PPP PAP Authentication Protocols, PAP Authentication Configuration, PPP CHAP Authentication Protocols, CHAP Authentication Configuration, and then I'll do a demonstration on configuring PAP and CHAP authentication. Okay, introduction to PPP. Point-to-point protocol is made out of HDLC protocol for encapsulation datagrams over point-to-point links. This is a layer 1 HDLC. Then it's made out of extensible link control protocol, LCP, to establish, configure, and test the data link connection. Thirdly, it's made out of family of network control protocols, NCPs, for establishing and configuring different network layer protocols, IPv4, IPv6, AppleTalk, and novel IPX. Now in this layer it's very good, it's better, it's got advantages to other protocols, PPP, as it does establish LCP or link control protocol, establishes the connection, configures it, and tests the data link connection. Make sure that everything is working fine. Then we have a NCP, works with a different protocol. We can have IPv4, AppleTalk, novel IPX, everything is fine. NCP can handle those. When to use PPP? Now, if we have two Cisco routers, we will be using HDLC, and that's a default encapsulation because HDLC is a Cisco protocol. But if you have a Cisco router and a non-Cisco router, then you might have to use PPP because non-Cisco routers, they're not allowed to use HDLC, as that's a Cisco proprietary protocol. Advantage of PPP. Now PPP is non-proprietary. That means that two different vendors, they can use PPP. PPP includes many features not available in HDLC. First feature, that it's a great feature, is link quality management feature. Monitors the quality of the link. If too many errors are detected, PPP takes down the link. It's great. If it goes something's bad, then PPP will take the link down. Supports PAP and CHAP authentication. Two different kind of authentication they're allowed in PPP. So, advantages, we have authentication and a link quality. PPP layered architecture. So if we have a Cisco and a non-Cisco router, LCP, if you're using a PPP, LCP, link control protocol, sets up the PPP connection and its parameters. Then, after you set up the link up there, it hands over to the NCP. NCP handles higher layer protocols configuration. It can use IP, it can use IPX, and so on. Then when it's done, NCP hands over to LCP again, which will terminate the PPP connection. So, LCP will handle variant limits on packet sizes, detect common misconfiguration errors, it will terminate the link, determine when a link is functioning properly or when it's failing. If it starts failing, it will bring down the link. NCP handles a higher layer, so PPP permits multiple network layer protocols to operate on the same communication link. So if this is our link, we can have a different network protocol layers to work. For every network layer protocol used, PPP uses a separate NCP. So different NCP for different network layer. So establishing a PPP session. The first phase is link establishing. So let's negotiate. Before PPP exchanges any network layer datagram, LCP, link control protocol, must first open the connection and negotiate configuration options. This phase is complete when the receiving router sends a configuration acknowledgement frame back to the router. This is layer 2, so we are talking frames here. Then it's phase 2. Determine link quality. Phase 2. LCP tests the link to determine whether the link quality is sufficient to bring up the network layer. If the link quality is not sufficient, then it's not going to bother with NCP. Then phase 3, network protocol negotiation. After the LCP has finished the link quality determination phase, the appropriate NCP can separately configure the network layer protocols and bring them up and take them down at any time. Configuration options that we have with PPP are authentication. Two types of authentication we have: PAP, Password Authentication Protocol, and CHAP, Challenge Handshake Authentication Protocol. We have compression. It's a great feature. We can use stacker and predictor for our compression. Then we have a multi-link. If we want to combine two or more channels to increase the bandwidth, then we can use multi-link. The configuration options, we have authentication. Two authentication choices that we have: Password Authentication Protocol, PAP, and Challenge Handshake Authentication Protocol, CHAP. Compression increases the effective throughput on PPP connection by reducing the amount of data in the frame that must travel across the link. We have two compression protocols, stacker and predictor. Then error detection. Identify a fault condition. The quality and magic number option help ensure a reliable, loop-free data link. PPP callback. Excellent feature. PPP callback is used to enhance the security. Now, Cisco routers can be the callback client or a callback server. The client makes the initial call, requests the server to call it back, and terminates initial call. It's a great security. I phone you, I hang up, I'll request for you to phone me, then I'll hang up, and if you phone me, then I know that you know my number, and this is a great enhancement on our security. The command for that is PPP callback, accept or request. Then multi-link. This alternative provides load balancing over the router interfaces that PPP uses. Basic configuration for PPP. Here we put the hostname, Cisco router, interface serial 000, now IP address, we're all used to this, we put the commands, and then encapsulation PPP. Before we type this command, none of the PPP commands will be available, subcommands I should say. Now, after we put the encapsulation PPP, now all the rest of the commands or subcommands that will be available. Do you remember what's the default in the Cisco routers? Default encapsulation. Well, here we go. The default is HDLC. Then the next command that we could use is compress, and then we can choose either predictor or stack. The next command is PPP quality. So what's our quality in the percentage? How low can we take for the quality to think it as failing and we want to bring the link down? So 80%, maybe that's a bit too low, but you have a range between 1 to 100. And multi-link, PPP multi-link, PPP multi-link group 1, or whatever you want to name. Now PPP multi-link and PPP multi-link group 1, for example, in this example, you have to enable it on the two interfaces that you want to join them or bundle them into one group. So same command in every interface you want the multi-link. Verifying PPP encapsulation configuration. So the commands we have: show interface, display statistics for all interfaces configured on a router or access server. Show interface serial, displays information about serial interface. Debug command, debug PPP, that's going to give you lots of information. Cisco does not recommend to use debug in the production line. And undebug all, turns off all debugging displays. PPP PAP Authentication Protocol. Now PAP Authentication Protocol, it uses like two-way handshake really. So R1 sends a PAP username and password, and then a non-Cisco router is going to receive this and it will evaluate username and password against its local database. And if it's a match, it will be accept, or if it's a if it doesn't match, then it will be reject. So PPP is very basic two-way process. There is no encryption. The username and password are sent in the plain text. Now that should make a big alarm on you. You should never use PAP, because the username and password are sent in the wire in the clear text. So if anyone is listening, they can see the password and username. If it's accepted, the connection is allowed. So to configure PAP authentication, we have a hostname Cisco this time. Hostname Cisco. And then we create a local database. Username other, password Cisco 1. Now username other is the name or the host name of the neighboring router that you're going to authenticate with. So if you can see up here, the name of this router is other, or the host name of this router is other, and that's what we're going to create our database. Username, the name of that router, other, and the password Cisco 01. Then the rest of the command, we learn these: encapsulation PPP. We do the mirror configuration on the other side. Then PPP authentication PAP. So we have to tell what kind of authentication. Are we going to use PAP or CHAP? Then PPP PAP send username Cisco and password Cisco 1. So what are we going to send to the neighboring router? On this side, again, the mirror configuration. PPP send username other, that's my host name, and the password Cisco 1. CHAP authentication protocol is three-way handshake. So first we have a challenge. Router initiates the three-way handshake and it sends a challenge message to router 1. Now router 1 will reply with the username and password. So it will reply to that challenge with the username and password, but it's in message digest 5. So it's one-way hashing. Then the router will actually evaluate the username and password or that message digest, and it will compare with the database. It will create its own message digest and it will compare these two message digests, and if there's same, they will be accept, or if not, then it will be reject. CHAP conducts periodic challenges to make sure that the remote node still has a valid password value. Though it's not like PAP. PAP will only do it at the start of the conversation, the authentication. CHAP, no. CHAP will do it at the start and it will continue doing it while the communication is going. The password value is variable and changes unpredictably while the link exists. The remote node responds with a value calculated using a one-way hashing system or function, which is a typically message digest 5, MD5, based on the password and challenge message. CHAP authentication configuration. Again, same configuration we had so far with the host name Cisco, username other, password Cisco 1. That was our database. So we created a local database here. And then we just say encapsulation CHAP. We don't have to say, and for CHAP, we don't have to say anything, send username or send anything. That's it. Encapsulation CHAP, and you're done with this. Okay, now I will do a configuration demo into configuring PAP and CHAP authentication. Now this is a packet tracer activity 2.4.6, configuring PAP and CHAP authentication. First, with this demo, we're gonna enable OSPF here. OSPF first as a routing protocol, and then we will do the default route, and then we'll enable the PAP and CHAP. Okay, here we go. Now packet tracer, I've got it open here. There we go. The first configuration, I will do it on enabling OSPF. So I'll start a notepad here. All my configuration, I like to do them in the notepad, so then I can just copy and paste them. Nice and easy. Okay, so I'll move it here, and I'm just going to increase the font a little bit so you can see a little bit better. A bit more, maybe 14. Yeah, that sounds better. Okay, so this configuration is for R1, and we're gonna say router OSPF 0, oh sorry, OSPF 1, we can't do 0, 0 is not allowed. And then network 192.168.10.0, and then the wildcard mask 0.0.255 in the end, and then area, what area it belongs to. So it belongs to area 0. Okay, so this is our configuration. Router OSPF 1, network 192.168.10.0, and then the wildcard mask 0, meaning that match that, another 0, match 168, another 0, match 10, and then last 0 is don't care, match anything, and area 0. So that's the network the router 1 is advertising. It will advertise its local connected networks only. The next advertisement will be for the network that is connected towards router 2. So that will be network 10.1.1.0 and then 0.0.0.3 because it's /30. Area 0. Okay, we'll do the same configuration for the other two routers. So they will be for router 2, router OSPF 1. Now this doesn't have to match. Remember, you shouldn't know this from the OSPF exercise. So router OSPF 1, network 10.1.1.0, and the wildcard mask 3, area 0. And then another network that is connected with 10.2.2.0. So you will say network 10.2.2.0, and the wildcard mask again the same, 0. So because it's /30. Okay, so then we got to the third router, R3. This is going to be again router OSPF 1, network 10.2.2.0, 0.0.0.3, area 0, and network, what's the network here? 192.168.30.0. Okay, so network 192.168.30.0, and the wildcard mask 0.0.0.255, area 0. Now router 2 has a like a network towards the ISP. I'm not going to advertise that because we're going to advertise it as a default network, default route for these two routers. Okay, so we have our configuration so far done. So we're just going to copy and paste. So I'm going to I highlight this, right click, copy, go to router 1, Cisco, enable, class, config T, and right click and paste. Okay, so that configuration is fine, no errors here. I will go again to my notepad and copy the rest of the commands for router 2. So copy, go to router 2, Cisco, enable, config T, paste. Okay, it's all done. And I'm going to go again to my notepad and copy the commands for router 3. Cisco, enable, class, config T, and paste the commands there. Okay, so do you remember the commands, how is to check for the neighbors? Router 2. Now router 2 should have 2 neighbors. And here I could have stayed there and just put do in front. Show IP OSPF neighbor. Okay, as you can see, we have a one neighbor. That's router 1, and that's router 3, the second neighbor. Show IP route to see if we have any routes. Yep, we have router 1 routes and router 2's routes. Okay, so good. This configuration, everything is done. So now we're gonna just give that default route. So we're gonna create a default route on router 2. So I'll open the notepad. So this configuration now will be for router 2. IP route, static route, all zeros. and this is going to the interface serial 0/1/0 to that interface up there. So that will be default route coming from anywhere, going out from this interface. Okay, I can just copy that, go to router 2, config t, and paste it there. Excellent, no error there. Now we are gonna like advertise this default route to the neighbor routers. The command that we're gonna do that is by default information originate. Okay, so go to the router 2 again. I have to go to the router OSPF 1 and default information originate. Okay, now since we have a static route enabled there, and we put this command, the default information originate, now all the default routes should be originated to router 1 and router 2. Oh, sorry, router 3. If we don't have the static route, but we still want to originate the default route, there's a command here in the end. There should be always. It's not supported in packet tracer, but you can just type in the end always, and it will always originate a default route, router 2. So if I go to router 1 and say here do show IP route, I can see the gateway to the last resort is 10.1.1.2, which is router 2, to network with all zeros, which means any network. Okay, and here's the OSPF. We learned it from OSPF. Excellent. So now this communication should be, everything should be working fine. Now this from the part 1, if you remember, this PC, the IP address was 192.168.10.10, and this PC here, the IP address was 192.168.30.10, if I'm not mistaken. I'm just going to go and check that. So open desktop 30.10, yep, and 10.10, yep, that's fine. So what we're going to do is now PC1 is going to try and ping PC3 just to see if there is a communication out there. So run the command prompt and say ping 192.168.30.10. Okay, we might lose the first ping. Here we go. Remember what's that? Why we lost that? ARP, yeah, Address Resolution Protocol. Now we have a replies. So now we have a address resolution protocol. So if we are pinging again, we're not going to lose any packets. Excellent. Okay, there is a communication. Now we're going to configure the PAP authentication, and then after that we're going to configure CHAP authentication. So between these two routers, R1 and R2, we're going to have a PAP authentication. So PAP here, let me write, and it's going to be CHAP on this side. Okay, so first we have to go to router 1 and enable, like, create that database. So I'm gonna go to router 1. Let me just put like a separator here. Okay, so R1, we create a database. Username, so the username is gonna be R2, and password Cisco123. That's it. We just created the database. Username R2, password Cisco123. Then we're going to go to the interface. So interface serial all zeros, 3 zeros, encapsulation, PPP. Then PPP authentication, that's it. PAP. So PPP authentication PAP. And PPP PAP send username. What username we're gonna send? We're gonna send our username, so our host name, which is gonna be R1, and then password Cisco123. Excellent. Okay, so I'm gonna copy all this text to router 1. Go down, enter, yep. No, I just made a different password. So Cisco123 we said. Highlight that, right click, copy. Gonna go to R1, right click, paste. Now there's not any errors, everything is fine still, didn't give us any mistake on spelling or anything. But the problem is that the neighbor, the OSPF neighbor that we had, adjacency, it's gone down, network down, interface down or detached. It's down because we have created PPP authentication on this side, and on this side we have got no authentication. So we have to configure R2 with the similar commands towards R1. So in R2, let's just make some space here, yep. R2, we say username, then we're going to create that database. So R1 and password Cisco 123. So we're creating a database. We're saying if any packets comes on this interface that they have a username R1 with a password of Cisco 123, allow it. And then interface serial 000, encapsulation PPP Authentication PAP, PPP PAP, send username R2 with password Cisco 123. Now, do you remember what was the problem with PAP? Well, PAP was sending password in clear text. So if anybody is listening or kind of like getting these messages, now they're gonna see our username and password because it's on clear text. So I'm gonna copy that text, right click, copy, and when I paste in R2, I should get that adjacency back. So yep, I can do it from here. I don't have to exit here, I can just do it right here. But okay, exit, paste. Okay, there was no errors, we didn't see any errors, and the adjacency is just gone up. Do show yeah, there we go, loading done. The port has gone up, and then we just have a neighbor come up as well. Okay, excellent. Do show IP interface, that's all I was going to do. Do show IP interface brief, and you're gonna see it here, but if I just make it this bit larger, okay, here all the interfaces are up, everything is working fine. Now the CHAP is done between R2 and R3. So what we're gonna do is PAP is done, not CHAP. We're gonna do CHAP authentication between R2 and R3. So to configure a CHAP authentication, first I'm gonna go to R2. Let me just copy this separator. Okay, this is going to be R2 configuration. So first we're going to say username R3, what we're expecting, and password Cisco 123. And then we're going to go to the interface that connects R2 with R3. So interface serial 001, encapsulation PPP, then PPP Authentication CHAP, encapsulation PPP Authentication CHAP. That's all we have to do here with the CHAP. We don't have to worry about sending username and password, everything will be taken care of. So we do similar configuration to R3. So we do username R2 this time, and password Cisco 123. And then we go to the interface that connects us with R2, which is this interface, serial 001. So if I open the notepad again, interface S04/04/1, encapsulation PPP Authentication CHAP. Okay, So when I put this in R3, I'll do it with R3 first. When I put this, copy these commands to R3, I should lose the communication with R2. So right click, copy, go to the R3, Cisco, enable, class, go to global configuration mode, and then paste in there. Okay, everything fine, no errors, no typing errors. And then, yeah, main interface is just gone down. It's not showing everything, but here, if I just extend these, you can see line protocol on interface S001, change state to down. Then we have a OSPF adjacency error. Well, not error, informational. It's gone from full to down. Neighbor, down. Interface, down or detached. Yeah, we know why. We just configured a CHAP and we haven't done it on the router 2. So I'm just going to highlight all the commands for router 2. Right click, copy, go to router 2. And after I paste those commands, I'm thinking the neighbors are going to come up. Okay, first the interface gone up, change state to up, interface 0001, and very quickly there should be a new neighbor adjacency with R3. There we go. Loading done to full, loading done, from loading to full. So that means that everything is back to normal. And show IP OSPF neighbor. Yep, same as we had before. 2 neighbors. Okay, that concludes the demonstration onto configuring PAP and CHAP authentication. A few commands I will see here. Well, let's see if they work in the packet tracer. Debug, PPP authentication. Yep, we can see that. Authentication, debug the authentication. If I shut this command, this interface, so interface S001, shut, and then same time I should try and bring R2 so we can see it. Yeah, R2, I'll just put it here in the corner a little bit, and then I'll bring this interface back up, and hopefully we can see some authentication configuration. So the interface is down, so show IP interface brief, the serial 001. Yep, that's the interface. Administratively down because I did not just shut down. Now to bring it up, I'll say no shutdown. There we go. Well, you're not going to see a lot of information on the packet tracer, but we'll see a incoming information and some outgoing information. Request sent, closed. You will see a bit more information if you do it on the physical router, which I would recommend. Anyway, have a good night. Thank you very much. Thank you for listening, and I'll see you in the next future videos. Bye.